This chapter is devoted to creating a custom piece of family content. What I aim to do here is give you a high-level overview of how the family editor works and some of the standard best practices in which to follow. So let's start with some of the assumptions. I'm assuming that we want to create a model element family and that we want that element to be parametric. And by parametric, I mean that we want it to be flexible in some way. Now, those assumptions are important because they will influence the way that we approach the creation of this family. There are many kinds of families in Revit, and here's just a short list. And any of these can be parametric or not. If you're creating a detail element family or a symbol family, and you're creating one that doesn't need parametric behavior, then you might not need to do all the steps that we will showcase here in this chapter. So I just wanted to point that out so that you can keep that in mind. But assuming that you do want to make a flexible element or a parametric family, then here are the basic steps that you will typically follow. First, you want to choose an appropriate family template. This will impart certain overall basic behavior on your family, like its category and hosting behavior. Next, you'll typically add reference planes. These establish the framework or overall structure of the family. It's similar to the project environment where we use levels and grids to form the overall structure, but in the family editor, reference planes are going to serve this purpose. Next, you'll add dimensions to those reference planes, and we typically assign either parameters or constraints to the dimensions. Both can be thought of as rules that govern the family as it flexes or transforms. A parameter is a rule or a behavior that can be edited by the end user from within the project. This means that the end user will be able to manipulate that parameter and thereby change the overall configuration of the family in some way. A constraint, on the other hand, is a rule that the end user cannot manipulate. So it's built into the family, or it becomes a fixed rule, not variable. I like to think of both constraints and parameters as adding smarts to the family. Once you've created this flexible framework, we then turn our attention to building the geometry. So we have an awful lot of setup to do before we ever get around to creating geometry. But once we've built all that framework and made sure that everything is working correctly, then usually the making of the geometry ends up being the easy part. Finally, and perhaps the most important thing that we can do while working in the family editor is flex and flex often. Flex is Revit's word for test it out. We're making a flexible element family, therefore we want to flex it often to make sure that it's functioning properly and it doesn't break in some unexpected way. You want to flex often as you work through your family editor exercise. This is the best way to catch issues as they occur and solve them right away, so flexing often is critical. That summarizes the basic workflow that we're going to follow. So now all that remains is for us to jump in and start creating our first parametric model family. In this video, we're going to begin a multi-step process to create a custom pool table family. In each video in this chapter, we'll walk through a different step in the process of creating this family. And in this video, we're going to start by just simply choosing an appropriate template for building the family and getting it set up and configured the way that we want. So I'm starting here on the home screen, and over here on the left, you have buttons to either open an existing family or create a new one. So what we want to do is create a new one. So I'm going to click that. Now that should take you right to a collection of template files in a folder. Mine went to the English Imperial folder because that's the version that I'm working in. If you're working in metric, it should have gone to that location. If for some reason it did not go to a folder like this and does not show you a list of templates, the template that I'm going to be using for this family, I've provided with the exercise files in a folder called OTB, so you can access it from there instead. Now, what I'd like you to do first is single click, don't double click, single click the first item on the list here and note the preview window over on the right. And then just use the down arrow on your keyboard and start moving through the various templates. And all I want you to see is that every one of these is actually quite different. Now, when you look at the names of the families, the name is telling you two important pieces of information. It's telling you the category, which is probably the most important thing, but it's also telling you the hosting behavior. So I'm going to stop here at these electrical items. And you can see that there are 3 electrical fixture templates. There's an electrical fixture ceiling-based, an electrical fixture wall-based, and then just simply an electrical fixture. So the difference is that this electrical fixture template would create a non-hosted family, one that does not require a host, where this one would require a wall host and this one would require a ceiling host. So we're not going to get into hosted families in this exercise, but it is something to be aware of if you start getting serious about creating family content. Then you definitely want to consider that. And the choice you make here is kind of important because it's rather difficult to adjust hosting behavior later. It's a little easier to change the category later, but just the same, it's a good idea to select an appropriate category right from the start. So in our case, we're making a pool table, so I think the furniture category is the best choice for that. And there's only one template for furniture, so it makes our choice easy. We don't have any hosted furniture templates in this case. So I'm going to select that and click Open. Okay, so we're now in an environment called the Family Editor. And I want to show you some clues how you can tell that you're in the Family Editor. The first is on the ribbon. You'll notice that we've got this Forms panel here, and there are several shapes that you can draw. So that usually appears when you're in the Family Editor. Next, on the Properties palette, it'll tell you you're in a family right here. So in this case, it says Family Furniture, but it would say a different category if you've opened up a different template. But the fact that it says Family indicates that we're in the Family Editor. Now, the Family Editor does have a project browser, just like the project environment does, but it's usually much simpler. So if you look at the views that are available here, you can see that it's a much simpler collection of views than what we've seen in other files that we've been in. And then finally, probably the easiest way to tell that you're in the Family Editor is the presence of this Family Editor panel here on the ribbon. And the interesting thing about that panel is it will persist regardless of which ribbon tab you're in. So if I choose a different ribbon tab, notice that I continue to have that Family Editor panel to the right. Now I'm going to go back to the Create tab. Now, this particular template that we opened, the furniture template, actually opened up with 4 separate views. So notice that I have a right elevation view, I have a 3D view, I have a front elevation view, and I have a ref level floor plan. Now, each of the views is showing at least some reference planes in a level, except for the 3D view. That one is empty. So I think it might be nice for orientation purposes to go ahead and turn on the levels here. So let's click on the View 1 3D view. Then we're going to go to the View tab and Visibility Graphics, or type VG. So it's just like in the project environment, Visibility Graphics, except that when you get here, it's much simpler. There's only a few things that you can control. Let's go to Annotation Categories, turn on Levels, and click OK. Now, initially, you're not going to see anything change, but if you come over here to the View Cube over on the corner of the screen and click the top corner, it will spin the view around, and then we will see the level displayed there. Now, what I'd like to do is tile all of these windows on screen next to one another. It's not required that you do that, but it can be a nice way to work in the Family Editor. So also on the View tab, if you click the Tile Views or type WT, then you'll see that we now have 4 tiles. And then finally, using the flyout on the navigation bar and choosing Zoom All to fit, or you can type the keyboard shortcut of ZA. We're now going to zoom each of the views so that we can see everything in those views. So at this point, that's the basic setup. We've got the template. We've configured it the way we want. So let's go to File menu and choose Save. Now, because this is the first time we're saving it, it's actually performing a save as. You can place this file wherever you like. I'm going to put it on my desktop. You can call it whatever you like. I'm going to call it Pool Table. And this next thing is optional, but I like to do it. When I'm working on a family, I like to create a version number. This allows me to save a particular version at one state and then go off and try something else. And then maybe if I don't like that, I can go back to the original version easily enough. So I'm going to call this V1 for now. And eventually, when you settle on the final version, you can remove the version number from the name, and we'll do that in a future video. But before we save this, let's click the Options button here. And there are some options we can configure. So we've seen maximum number of backups before in the project environment. I think in the family environment, we can set that to 1. There's really no reason to have lots of backups of this family, but this is up to you. If you would prefer to have more backups, you can leave that set to whatever number you like. But the really useful thing here is the thumbnail preview. So what I want to do is set the source of this to the 3D view, and then I'll check this box to make sure that it regenerates that. We'll click OK. We'll save it. And so now whenever this file saves, it will save with the 3D view, regardless of which view we left active. So that completes the creation of the family from a template and the initial save. In the next video, we will move on to the next step of the process. In this video, I want to show you what happens when you save a file with multiple open views. So before we continue working on our pool table family, I thought it would be useful to go through this because it could be a time saver if you know how to save the file with multiple views open already. Otherwise, when you close a file, if you don't know the trick, you'll have to reopen each of the views that you want to work with each time you open the file. So I'm going to reopen my pool table V1 file from the recent files. Right here, you can see it's listed there. If yours is not listed there, then you can just do open family here and browse to it wherever you saved it. But since mine is right here, I will just simply click on it to open that file up. Now, notice that it came in with 4 view tabs across the top. Before I get to those 4 view tabs, I want to talk about the 3D view because it did open with my 3D view active, but it's looking at it like head on from the front view here. And I want to adjust that too. So there's 2 things we're going to look at in this video. So what I'm going to do is just kind of click this top corner of the view cube here to orient that more to an axonometric orientation. If you want to preserve that the next time you open the file, what you need to do is right click the view cube and choose Save View. So that's the trick to preserving the orientation of the view, but there's one small gotcha that I want to make you aware of. If you're using the default 3D view, so if you click the little birdhouse here and it creates that view with the curly brackets in the name, you won't be able to save that. So if you choose Save View, it's going to force you to rename it. So just something to be aware of. I don't care in this case. Actually, I'm going to delete the default 3D view, and I'm fine with just working with this one called View 1. Okay, so getting back to the question of the multiple views open, let me show you what happens if you don't save this correctly. I'm going to go to the File menu here and choose Close. When I do, it's going to ask me if I want to save my changes to the version 1 pool table. I'm going to answer yes. Now, it's still listed right here. It looks exactly the same, so it doesn't appear like anything has changed. But notice what happens now if I reopen this file. I only have View 1 open. Now, it did remember the orientation that I asked for, so that's at least a little bit of an improvement. But now, if I wanted to work in the floor plan and the elevation views, I'd have to reopen those views. Now, it may not be a big deal to you, so if that's the case, don't worry about it. But it sure can be nice if you have a collection of standard views open when you open up the view. So what I'm going to do is reopen all of the views that were previously there. Then you want to activate the one that you want to be predominant, let's say. And then finally, here's the trick. If I want this file to reopen with those 4 views again the next time I close and open it, I need to make sure that I go to the View tab and tile it before I save. Now, you don't have to zoom. It's not necessary. You can if you want to, but all you need to do is make sure you save it in this tiled state. So I'm going to click Save here. Then I'll go to File, choose Close, close the file, and now watch the difference. When I reopen the pool table, now it will open with the 4 views. So as you work through the family editor exercise, if you're closing and opening files, I just wanted you to be aware of that if you're wondering why my files open up on screen with multiple tiled views and I'm able to just simply do WT and yours is coming in with only 1, it's because perhaps you click the little X here. So it's very important that you don't X out these views as you're closing. Just simply keep it tiled save the file and close it, and you should be good to go. In this video, we're going to begin laying out the framework that we need to drive the geometry in our family, and that is done with a series of reference planes that are driven by dimensions that are either constrained or parameterized. So we're going to look at all of that here in this video. Now, I'm working in this file that has 4 tiled views. If you're not sure how I got here, then I recommend you go back and watch the earlier video where I discussed how to save files this way and how to reopen them. So what I want to do is jump right in and start talking about reference planes. And I'm going to work in the ref level floor plan view. So just click anywhere in this view. And then let's start with these 2 reference planes right here and here. If you're not able to highlight or select them, then it's very important that you use this little drop down here underneath the pointer tool and make sure that select pinned elements is turned on. Notice that these 2 reference planes both have a push pin on them, and the push pin is used to prevent you from changing the element. We won't be able to move it, rotate it, delete it. And that's important because both of these reference planes are indicating where the origin of this family is. And you probably don't want that to move in any way. Okay, now what we're going to do is create our own reference planes to begin defining the extent of this family. So to do that, let's go to the Create tab. And you want to use this reference plane button here. RP is the shortcut. Make sure you're choosing reference plane, not reference line. Those are not at all the same thing. So pay close attention, make sure it's reference plane that you're choosing. So I'm going to start above the existing reference plane over here to the right, and I'm going to inset just a little bit and then draw this horizontally like so. There's a dimension that appears right here. I will click to edit that dimension, and in the imperial file, I'm going to use 2 feet in metric. That would be 600 millimeters. There's also a label right here that you can edit that says click to name. So I'm going to do that and call this back edge and enter that. So now I'm still in the reference plane tool. I'm going to start just above and to the right of the endpoint over here, click and draw it straight down this time. Edit this dimension, make that 4 feet imperial or 1200 millimeters in metric, and then click to name, and I'll call this left edge. Now you could continue in this fashion to create right edge and front edge, but I prefer to use the mirror tool. So I'm going to click the modify tool to cancel out. I'm going to select the back edge, go to mirror pick axis. I'm going to use the center line as the mirror axis, and that creates a new reference plane at the correct distance, but I do want to change the name to something more appropriate like front edge. And then let's repeat for this vertical one, mirroring it around this reference plane and calling this right edge. So those are the reference planes that will ultimately define the overall size and shape of our pool table. But at the moment, those reference planes are just randomly placed and could easily be moved anywhere that you like. Now I'm going to undo that. Okay, so what I want to do now is start pinning down their behavior a little bit and making it a little bit more predictable. So we're going to do that with dimensions. It's the same dimension tool that you use in the project environment, aligned dimension, or you can type DI. I'm going to create a total of 4 dimensions here. The first one is going to go from left to center to right, and I'll just place it up here somewhere. Then I'm going to do one from left to right and place that above the previous one. Then let's repeat in this direction, from back to center to front, and then from back to front, and we'll place it here. Let's click the modify tool to cancel. And as you can see, the text is a little small, difficult to read right now. Turns out that in the family editor, you can change the scale to anything you want because nobody's ever going to see these views. These views are only here for the family editor. So I'm going to increase the scale to 1/4 inch equals a foot and then zoom in a touch. And now I can read everything a little bit better. If you're working in metric, you can use 1 to 50. Okay, so we've got dimensions, but they're still not driving the geometry yet. Notice that I can still move the reference plane freely, and all that happens is the dimensions will update. So I'm going to undo that. So what we're going to do is select the lower dimension here and toggle on its equality. Now doing that will now add a constraint to the behavior of the reference planes. So if I grab this reference plane and I move it now, notice that the other one moves the equal and opposite amount in the other direction. Okay, so now we're starting to make some progress. I'm going to undo, and then let's toggle on the equality for this guy as well. And then what we need to do is take the two numbered dimensions that remain and turn those into parameters. Now, the way we do that, we've already covered this process earlier in the course when we created something called a global parameter back in the project. The process is almost identical here in the family editor. So instead of labeling this dimension with a global parameter, that's in a project environment, we're going to label it with a family parameter. But the interface is the same. Notice the label drop down here. We don't currently have anything to choose from, so we're going to go right to this icon where we can create a new parameter and apply it as a label to this dimension. So I'm going to call this new parameter length. I'm going to leave it set as a type parameter, but I could toggle it to instance if I wanted to. We'll talk about that later. I'll click OK, and let's do the same thing with the 4-foot dimension or 1200 millimeter if you're working in metric. Let's create a new parameter, call it width, leave it type, click OK. And now finally, we can test the behavior of both of those parameters by simply selecting the dimension. That will activate the text. Click right on the text, type in a new value. I'll do 6 in imperial or 1800 millimeters in metric. Let's try the width now. I'll do 2 in imperial or 600 millimeters in metric. And assuming that the reference planes moved how you expected and the size of that rectangle got smaller and changed proportion, then congratulations, you have created your first parametric family. Now, there's still plenty more to do, so we're going to pick up right here in the next video and move on to the next step. In this video, we're going to discuss family types. Now, if you think about the hierarchy of elements in Revit that we talked about earlier in the course, every element has a category, it has a family, and it has a type. So we've been working on a pool table family here in this chapter so far, and the category for our pool table is furniture. And then the pool table version 1 is the current incarnation of our family. But so far, this family doesn't have any types. So let's discuss that a little bit and then talk about how to create some types. So let's consider some of the out-of-the-box families you might be familiar with, like this Corbu chair right here. If you have this chair, you may have noticed that when you select it and look on the properties palette that there is only one entry beneath the family and it has the same name as the family itself. So it's going to say Chair Corbu twice, essentially. Well, what's going on there is that inside that family, in the family editor, that family does not contain any types. So if you have a family like the Corbu chair with no types in it, then Revit will create one on the fly when you load it into a project because every object has to have a category, a family, and a type. So it will just simply make one and it will use the same name. So if you've ever wondered why sometimes you see the same name twice, that's usually why. There aren't any built-in types. Now contrast that to a family that does have built-in types, like this coffee table right here. When you open the type selector, you will see a list of available types there beneath that family. And you can see in this case that it's easy to switch from one size to another. And this is what it would look like in the family editor environment. You'll now see a list of types at the top of this family types dialog, and you'd be able to choose each one and configure its settings. So what we're going to do is switch over here to Revit now and create some family types for our pool table family. Now you can do that in this dialog right here. So it's on the properties panel. The button is called family types. And when you get here, it will display this window. So at the moment, this one looks like that Corbu chair example that I showed you a moment ago. The type name list at the top is grayed out. There aren't any types in this family. Now you will see some parameters listed here, and notice that that includes the 2 parameters that we created in the earlier video. What's interesting about this is if you select one of them by name, it will highlight in orange back in the view window. And then you even have some control over those parameters down at the bottom here. You could use this pencil icon to edit them. You could create new ones. You could delete them if they're no longer necessary, copy them, and then even change the order with these up and down buttons. So we're not going to do any of that right now. What we're going to do is stay focused on the top here, the type name. And if you use this small new type icon right here, you can create your first type. I'm going to keep the names here kind of generic and just simply call this one large. Now, for the actual values of these parameters, I'm going to use imperial units for both files, whether you're working in imperial or metric. The cut sheet that I'm working from is in inches. That's going to happen sometimes if you're trying to build a family based on manufacturer content. You won't get to decide what units they were working in. But watch this. In Revit, you can put in the unit and it will automatically do the conversion. So what I'm going to do is put in 88 inches. And regardless of which file you're working in, if you're working in imperial, when you enter that, it will format it as feet and inches. If you're working in metric, it will format it as the correct number of millimeters. So let's repeat that for the width, 44 inches. So make sure you're using that inch symbol, enter it, and it will do the conversion. Now we're going to click the apply button here and watch the reference planes in the background. They will adjust to match that new size. So now we're going to click the new button again. We're going to call this one small. And the small size is 78 inches long. Again, press enter to do the conversion. And it is 39 inches wide. Press enter to do the conversion and then click apply to see the change. So now here's the best part of creating family types. If you want to flex your family, and flex is just the word that we use to test things out. So you want to get in the habit of flexing often when you're working in the family editor. To flex, you simply choose the drop down here and pick a different size and click apply, and it will reapply those values in one step. So another way to think about family types is they are just a saved and named variation of your family. And now we can easily toggle between the two variations that we've created anytime that we need to here in this dialog. In this video, we're going to begin creating the solid geometry required to begin sculpting our pool table family. So I'm going to start with a simple extrusion. And I think the easiest place to build it would be in the floor plan view. So I'm going to click here in the ref level tab, and you'll see it turn bold here on the ribbon tab, and it also turns bold here on the project browser. And that's how I can tell that that's the active view. Then I'm going to put my mouse kind of near the center and just roll in a few clicks in order to zoom in and get a closer look at the reference plane structure that we established in the earlier video. If you look at your ribbon, you will see a series of forms. Here's our extrusion right here. These all have these little animated tooltips. So I do encourage you to kind of watch those. It gives you a general sense of what kind of things you'll be prompted for to create these forms. But an extrusion is just a simple sketch-based object that you can create in any closed shape. I'm going to click on that, and that takes me to the sketch mode for this extrusion. And for this one, we're going to keep it pretty simple and just use a rectangle shape. So I'm going to click that right here, and you want to simply snap from two opposite corners on the reference planes that we have here in our plan view. So I'm going to click there, opposite corner across to here, and click. And that's going to display these four little padlock symbols. And what I'm going to do is simply close each of those padlocks. That's all I need to do for the sketch. So I will click the finish button right here to finish that edit mode and create the 3D form. Now in the 3D view, it's in wireframe, and I think it will look a little nicer if we shade it. So I'm going to use the little visual style pop-up here and change that to shading. And now it looks a little bit more solid. Now, you recall that in an earlier video, we set up some types in this family. So it's always a good idea to get in the habit of flexing as you make changes. So we have added our new piece of solid geometry. Let's go to family types right here. And you can position this window so that you can see a few of the views at the same time. And then I'm just going to toggle to by small size, click apply. That box will get a little bit smaller. Everything's working correctly. Let's go back to the large size and click OK. All right, so that's our piece of solid geometry. Now I want to direct our attention to the vertical dimensions of this piece of solid geometry. The first thing about it is that it's sitting on the floor and I need to move it up. And the second thing is that it's too thick. So let's address both of those issues now. So I'm going to work here in this front view and I'll just zoom in a little bit. Now there's a variety of ways that you could adjust the height and thickness of this solid form. I like to do it with reference planes. It's not the only way, but it's the way that I'm going to show you here. Okay, it's my preference. So I'm going to go to the Create tab and click the Reference Plane tool, or RP. And what I want to do is click and drag across the top there to create a horizontal reference plane that's parallel to the ground. When it says click to name, I'm going to click right on there and label this tabletop. And then for the dimension, I'm going to click right in there, and imperial, I want to do 2 foot 7 inches. If you're working in metric, you can put 787 millimeters, 787. Now keep that dimension active, and there's a little make this temporary dimension permanent icon right here. I'm going to click that. That creates a dimension for that reference plane. I'll go to the modify tool to cancel out of the command, grab that dimension, drag it off to the side. And at this point, you're probably thinking that we will go up here and label it with a new parameter. And we certainly could do that like we did in plan view, but honestly, it's not really necessary in this case. So I want to point out that it's not always required that you create a parameter for every dimension. You certainly can do that, but if the dimension is a fixed value that doesn't need to flex, then what you can do instead is simply lock it. So when I lock it, that creates a constraint, and that constraint will ensure that this reference plane always remains at 2 foot 7 or 787 above the ground. Okay, so that's a perfectly appropriate way to deal with that reference plane location. Now I'm going to select the reference plane and go to my copy tool next. Pick a start point anywhere on screen, pull it straight down. And if you're working in imperial, you want to move it down 3 inches. If you're working in metric, you want to go down 76 millimeters. Cancel out of the command, come back and add a dimension between these two reference planes, pull it off to the side and lock it. And then finally come back and select that reference plane, click on its label and give it a name, and I'll call it underside. So we now have these two reference planes that we're going to use to relocate and change the thickness of our box. Now, I want to point out that on my screen, the label underside is below my reference plane. That's because when I drew the original reference plane, I started at the left and drew to the right. If you went the other way from right to left, notice that the label would be above the reference plane. That actually matters. Okay. So the reference plane has a positive and a negative direction. The label is on the negative side. So that means that anything created on this reference plane or this reference plane will extrude up. Anything created on this reference plane will extrude down. So if your labels are facing up, then what you want to do is use the little grip control here on the edge, drag that past itself, and notice that that flips the label, and then you can take the other endpoint and pull it back the other way. Now, mine was correct originally, so I'm just going to stretch it back again. But it is possible to reverse the direction of that reference plane, but you just want to make note of that before you continue. Okay, so now all we need to do is select this box and move it to that reference plane. Now, you might be thinking we're just going to use these little grips to do that, and you certainly could, but that's not my preferred way to do it. What I would rather do is leverage the Edit Work Plane tool right here. Now, if you click this choice, it will take you to a dialog where you can choose by name from the list. That's perfectly fine to do it that way. This is a little bit more convenient. Pick a plane, and there's a keyboard shortcut of PK. So all I need to do is click the underside reference plane
and the box will jump up to that location. And once again, if yours jumps up there and points down, then your reference plane is reversed. You'll need to go back and make some adjustments. Now, you could take this grip and stretch it down to here, but I prefer to use the align tool for this. Again, just different ways of doing the same thing. So I'm going to go to the align tool, pick the reference plane as my alignment edge, then the top of the box, and then I'm going to lock that to ensure that it stays attached. So that completes our first piece of solid geometry. In the next video, we will use a sweep solid form to create the bumper rail around our pool table.
In this video, we're going to continue creating solid geometry to represent our pool table, and we're going to move on to a sweep, and that's going to form the shape of the bumper rail that goes around the playing surface. Now, a sweep is a solid form that follows a path. So if you hover over any of these solid form tools and let the tooltip load, you'll see a small animation, and that animation will kind of show you the way that tool functions. So in the case of the sweep, you can see they're creating a path and then they're taking some shape and moving it along that path. And that's what we're going to be doing to create this bumper rail geometry that goes around our pool table. Now I'm going to work in the ref level floor plan. I'm going to zoom in nice and close. And then I want to make sure that the geometry I'm building references the reference planes and not the extrusion. The easiest way to ensure that is to temporarily hide the extrusion to get it out of our way. So I'm going to select it, go down to the sunglasses, choose hide element. Notice that puts me in temporary hide isolate mode just in the floor plan view. And now I can build my sweep relative to the reference planes without accidentally snapping to the geometry. In general, it's always preferable to reference planes or levels rather than other geometry. You usually get better results that way. Okay, so now I'm going to click over here to the Create tab, and I want to ensure that the sweep that I'm going to create goes to the correct work plane. So in the previous video, we used the edit work plane. Here I'm going to do set work plane. So you can create the object first and then later change its work plane, or you can set the work plane ahead of time and draw it directly. That's what we're going to do here. So we used pick a plane in the previous example. This time I'm going to click set work plane. That displays this dialog. And then here there's a name list and all of your named reference planes are listed here. So I want to draw my sweep at the height of the playing surface. So I'm going to choose reference plane playing surface as the choice there, click OK. And now I will be drawing this sketch up at that height. So next I'm going to go to the sweep tool, and when you get into the sweep, you have two options available right here. You can sketch the path or you can pick the path. So we're going to choose sketch the path, and this is going to allow us to draw the shape that we want our sweep to follow. So I'm going to start with a simple rectangle, and then I don't want to snap it right to the reference planes. What I want to do instead is offset it away from those reference planes by a little bit. So I'm going to put in 3 inches in imperial or 75 millimeters in metric. Then when I snap to one of these intersections, you'll see that the sketch that's being created is offset away from that by whatever value you typed in. Now you can tap the space bar and it will offset in the opposite direction. So just make sure that it is drawing the shape outside of the rectangle defined by the reference planes, and then click the opposite corner. So now what I want to do is blunt off all the corners. So I'm going to do that by switching to the line tool, and I'll just zoom in here in the upper left-hand corner and snap right to the intersection of the reference plane and the sketch line. But notice that it still has that offset applied to it. So before you click the second point, come up here to the options bar and just zero out the offset, and then you should be able to draw the second point like so. Switch to trim and extend a corner and trim that up. And then just simply repeat that on the other 4 corners. And when you're done, your path should look something like this. Now, notice this little red dot that appears on one of the edges. That dot has a little green dashed plane superimposed on it. Now, the easiest way to see it is in one of your elevation views. So the right elevation, in my case, is showing me that green dashed box as a plane that I'm looking directly at. That is the sketch plane for the profile that we're going to push along this path. So when you click finish here, you want to be looking at this view, okay, the right view. So I'm going to make that the active view. And then this is where we're going to finish the sweep. Now you have two options with the profile that you're using for the sweep. You could choose the edit profile button here, and that would put you in sketch mode, and you could just simply draw the shape, or it's possible to use a family to determine that shape. So I've created a profile family for this purpose to speed things up, and we're simply going to load that in here. A profile family is nothing but a 2D shape that you've drawn in the family editor that you can then reuse in more than one family. So I'm going to click load profile, and then I'll go to my desktop, my exercise files folder, and I'm going to select this rail family here, and you can kind of see the shape there in the preview on the right-hand side. And let's click open. And that loads that profile into this family file. And now I can simply select it by name from this drop-down list. So I'll choose rail, and you're going to see it appear right there on that little red dot. Now, it turns out that this profile can be moved around. So you can move it in any direction that you like. I'm going to do Control Z to put it back where it started from, but I'm going to move it a little bit more systematically using the Align tool. So I'm going to go to Align, pick this reference plane right here, and then the reference plane on the rail itself. And you'll see that we'll snug it over to the edge of the pool table geometry. And then I will click Finish, and the result of our sweep can be seen best in the 3D here. As we've done in several other examples, you should probably flex at this point just to make sure everything is working correctly. So there's the smaller size, here's the larger size, and that is working just fine. So in the next video, we'll keep going and add the pockets to the pool table. In this video, we're going to continue with the geometry required for our pool table, and we're going to move on to void forms. So solid forms are what we've created so far. They create actual physical objects. If you want to cut away from those objects, you can use a void form. So sometimes the way to create a more complex form is to create a solid first and then carve from that solid various voids to create the more complex shape. So that's what we're going to look at here, and we're going to use the void to create the pockets that cut into the surface of the pool table. Now, we could go directly to the void forms dropdown here, and notice that you get the same 5 shapes that are available as solid forms. And there's absolutely nothing wrong with doing it that way. I sometimes like to create it as a solid first to get the geometry correct first. And then once I'm satisfied with the geometry, then you can convert it to a void and apply it to your solid. And that's the workflow that I'm going to show you here. So it's just a matter of preference. It's not that one is more correct than the other. It's just two different ways of doing the same thing. So I'm going to work in the ref level floor plan initially, and I'm going to select the sweep, the bumper rail geometry, go to the temporary hide isolate, hide that element. Then I'm going to select the surface and hide that element as well. So I like to do that just because I like to be able to see the reference planes very clearly and make sure that I'm drawing my geometry relative to them. Next, I will go to the create panel, choose extrusion, and then I'm going to switch to a circle, and I'm going to draw a small circle right here at a 2-inch radius in imperial or 50 millimeters in metric. If you're getting a warning that says the element is too small, just zoom in and try again. And you should be able to, at a closer zoom, make a 2-inch or 50 millimeter circle. So we want 2 of them, one that is snapped to the center and the edge, and the other one that is snapped to the corner. I'm going to take this one that we snapped to the corner and go to my move tool, pick a start point, start moving to the right, and I want to move it 1 1/4 inches in imperial or 32 millimeters in metric. Then I'm going to select both circles and move them down the same amount. So 1 1/4 inches imperial or 32 millimeters metric. Once I've done that, I'll take just the one at the corner, mirror that to the other side. Then I will deselect, come back and select all three and mirror those to the other side like so. So you should now have a total of 6 circles, and they're all offset the same amount all the way around. I want to change the work plane for this geometry that I'm drawing. In the previous video, we set the work plane to the playing surface, and I want to sync it down to the underside. So what I'm going to do here is choose set work plane, and instead of playing surface, I'll choose underside, click OK, and now when I click finish, it should draw those cylinders, 6 of them, starting at the reference plane right here, and you can kind of see that very clearly in one of your elevation views. All right, so notice that here in 3D, if we kind of click away from it, that it's currently solid geometry. Well, I said that I wanted to get the shape correct first, and then when I was satisfied with it, I would convert it to a void. And that's what we're going to do now. We're going to select this object. Now notice that all 6 cylinders are part of the same extrusion, so you just need to click one and it will highlight all 6. Then we're going to come over here to the properties palette, scroll down, and there's a solid void parameter, and it's currently solid. You can simply change that to a void. Now, the reason I wanted to do it this way, other than that I like to do it that way to get the geometry correct first, is also I wanted to show you what a non-engaged void looks like. So notice that when you just have a freestanding void in your model, it will show up in this yellow transparent glass material. And that's how you can tell that that's a non-engaged void. So to engage that void with solids and to begin having it cut away from the solids, you use the cut tool. So I'm going to come up here to cut geometry, click that, select the element that you want to cut, the sweep, and then click the object you want to do the cutting with, the void, and notice that it will carve that shape out of the bumper material. I'm going to zoom in nice and close near one of the pockets. Notice I'm still in the cut tool. So you can pick a second object like the extrusion and then move near the edge where the void should be, and it's still there, and you can select the same void and have it cut more than one element. So now notice that we've used that one void to cut both pieces of geometry. And that completes our pockets for this pool table. So in the next video, we will give our pool table some legs so that it's not suspending, free floating in space here.
So there's just a little bit more geometry that we need to complete the form of our pool table. We need some legs, and in this video, we're going to build them using a blend. Now, I'm going to start here in the floor plan, ref level floor plan, and zoom in just a touch so that we can get a better look. And as we've done with other forms, I want to start with reference planes. So make sure you're using reference plane, not reference line. Keyboard shortcut is RP. And what I want to do is create 2 reference planes running vertically kind of inside the pool table here. Now you'll notice that I'm creating them longer than the pool table, but shorter than the other reference planes. That's intentional. And I'm going to do the same thing for one running horizontally this way. So I'm creating it at a different length than the existing reference planes, but I'm making sure that it passes through the full length of the pool table. Now, the reason I like to do it that way, let's click the modify tool here to cancel out, is because it makes it much easier to dimension, and also visually it starts to establish a hierarchy. So I can tell visually that these 2 are related to one another because they're the same length, but they're different than these other ones. And then when I go to dimension, it's much easier to select them to place dimensions, because it's really important that you're dimensioning the reference planes and not directly to the solid geometry. So I'm going to create a dimension right there. Then I'm going to do the left edge to this one, and then the 2 reference planes to each other right there. Okay, so you can see that it was very easy for me to place those dimensions without accidentally dimensioning directly to the solid geometry. That's why I did it that way. So I'm going to select this reference plane, edit the dimension, and if you're working in imperial, I want that to be 3 inches. If you're working in metric, it should be 75 millimeters. Then I'm going to repeat that with this reference plane next and edit the value to the one next to it to 1 foot imperial or 300 in metric. And you want to make sure that you select that dimension and lock it. And in fact, you want to lock this one as well. So finally, we're going to select this one and modify this value, and this should be 6 inches in imperial or 150 in metric, and then we will lock that. And now we have all of those reference planes positioned where they need to go. Let's select the horizontal one and its dimension, go to mirror pick axis. We're going to pick the center line of the pool table right there. And if everything works correctly, it should mirror the dimension and lock it on the top half. Now, if it didn't do that for some reason, just simply add the dimension and lock it manually. So now we want to test all of that by just going to family types, choosing our small size, click apply. And because we locked all those dimensions, all those margins around the space for the leg should be maintained as it changes size. So that looks pretty good. I'll go back to the large size. And now we're ready to begin creating our solid form. Now that's going to be a blend. So we're going to go to create. Here's the blend tool. Now you can think of a blend as simply an extrusion with 2 sketches. So if you watch the little animation here, you can see that it's blending between the first sketch and the second one. So I will click the blend tool, and then over here on the ribbon, you have the same draw shapes that we've had for some of the other tools that we've looked at. I'm going to start with a simple rectangle. And then I'm going to come over here to the options bar and apply an offset. So if you're working in imperial, that's going to be 2 inches. If you're working in metric, it's going to be 50 millimeters. And then what I want to do is click one of the intersections of the reference planes we just drew and go to the opposite corner. But notice that the rectangle is going outside of the reference planes. Before you click the opposite corner, tap the space bar to flip it to the inside and then click. And that will create that inner rectangle. Now you go to edit top, and that will put you in the same sketch mode, but now you're drawing the top sketch. And we're going to stick with a rectangle, remove the offset. So set that back to 0. And this time we're going to use a radius, and let's use the same value, 2 inches imperial or 50 millimeters metric. And then when you snap to the opposite corners this time, that will round off the corners of the sketch. Now go ahead and close all these padlocks. And then you can click finish to complete the blend. Now we've got a couple issues here. The first is that the blend created up at the surface of the table. That's not really where we wanted it. And the second is, if I look at it maybe here in the front elevation, it's too short. Okay. Now the depth is actually controlled by this value right here on the ribbon, and it is possible for you to type that value in if you know what it is. We don't really need to do that though. We don't need to calculate what it is. We can do it another way instead, interactively on screen. But first, let's get it down to the correct location. So I'm going to select this blend, go to the drop down here, pick a work plane, and I'm going to pick the ref level to bring it down to the floor. Once we've done that, I will go to the Align tool, or AL, select that, and I'm going to pick the underside reference plane as what I want to align to, and then the top of the blend, and then lock that. Now, the reason I'm using the Align and the reason I'm using the reference plane is it's really important that you always establish your relationships between references and not directly on the geometry. Okay, it's just a standard best practice to do there. So finally, we're going to click back here in the plan view, select the blend, select both of these vertical reference planes. So I'm using my control key to get that, the dimension here and the dimension here. So if you look over here on the properties palette, it should say common 5. You've got 5 elements selected. That's 2 dimensions, 2 reference planes, and 1 blend. Go to mirror, pick axis, pick the center line. That should mirror everything around to the other side. Now, it looks like it wasn't happy with the 6-inch dimension. Not a big deal. You can simply create a new dimension. Just make sure to lock it. So once you've done that, it's a good idea to flex. So we can do this in whatever view is convenient. We'll go to our small size. We'll click apply. Everything should be adjusting as expected. And if it is, you can go back to large and click OK. And so we're just about done now with our pool table. That's the major geometry that we need. There's still a few finishing touches, but we will save those for the next video.
In this video, there's a few finishing touches I would like to apply to this pool table. One is I would like to add a material to the playing surface to get that really recognizable green felt. And then I also want to add some accessories to the pool table. So let's start with the material. We're going to get there on the Manage tab. And what we need to do is go to the Materials dialog and create a material first. Now, in the Materials dialog, it's possible to search and look for a suitable material, but the chances that there is a green felt material here already is pretty slim. So what we're simply going to do is come down here to the new icon and we're going to create a new material. We can right click that new material and we can rename it. And I'll just call it green felt. And then it has two sets of properties over here that we want to consider: graphics and appearance. Let's jump over to appearance. Now, on the Appearance tab, you can expand the information, and the name of the appearance information is separate from the name of the material. Now, it doesn't have to be, so I think it'll be less confusing if we change generic 1 to green felt as well. But it won't do that automatically. So if you want the names to match, you need to do that yourself. Now, let me just make this a little larger, just so we can see the properties here a little bit better. There are a number of properties here, but honestly, all we really care about is the color. So right here, it's using a medium gray. All we need to do is click that, and you can choose one of the built-in greens right here, or you can pick something off the color wheel, or you could drag the slider, but I think that green looks fine, so I'm just going to accept that. And that's really all we need to do for this example, is apply a green color. Now, back to the Graphics tab. I mentioned there was two tabs. Appearance is used whenever you display textures. So that'll be used in realistic shading or textures shading. Graphics is used in other views. So hidden line, shaded, consistent colors, and so on. If we leave it the way it is right now, when we go to shading, it'll still be gray and you'll be confused. Wait a minute, I thought I assigned the color to green. Why isn't it green? So the easiest solution is to just check this little box right here, and that synchronizes those two colors. So now the render appearance color that's used in rendering is going to also apply to shading. So that's it. That's all we want to do for this material. Let's click OK. And now we need to apply that material to the playing surface. So select the extrusion and then look at the properties palette. So we're going to scroll down here, and there's a material property right here. And you could assign this material to the playing surface in one of two ways. If you click right where it says by category, a small browse button appears. You could click that and you're right back in the material editor. You could select it, click OK. I'm going to actually cancel that because I don't want to assign it that way. What I want to do instead is use this small icon right next to the by category that says Associate Family Parameter. This is going to make it more flexible, but it's going to take a few extra steps. Here in this dialog, we don't have any material parameters just yet. So down at the bottom, there's a new parameter icon, and we can create one. And if this looks similar to what we did earlier with dimensions, then you are correct, because this is just a different kind of parameter. So instead of this being a length dimension like we did for width and length, this is a material parameter. So I'm going to give this a name, maybe playing surface. And that's just the name of the material that we're assigning to this surface. Let's click OK. OK again. Notice that this grays out now. You can't change it. And there's an equal sign on the Associate Family Parameter button indicating that this value is being driven by a parameter. But here's where, if this is the first time you're doing this and you click away to deselect it, you might start getting frustrated because you're saying to yourself now, where's the green felt? Why didn't it change? Well, think of what we just created as more of a material placeholder. So we've just made it possible to assign a material to the surface. And more importantly, we've made it a parameter so it's flexible. So let me show you what I mean. Let's go back to family types. And notice that playing surface is now one of my parameters. And the reason it's still gray is because here it's still set to by category. This is where we're going to browse to the material window, choose our green felt, and click OK. And now finally, if you click apply, it will apply that to the surface of the pool table. However, I want to point out one last thing here. switch to the small size and click apply, and notice that it goes back to being gray. And that's because the way we set it up, each type can have its own material designation. So let's say you wanted to create red felt or brown felt. You could go back to the material browser, create other colors, and then you could have different types that were assigned to different colors. That's the reason to do it this way. In our example, though, I'm going to keep it simple and just assign them both to the green felt. But if you want to explore materials more on your own later, feel free to add some additional materials and try that out. So I want to reset back to the large size. So I'll click OK there. And then as a final finishing touch, I want to add some accessories to the pool table. Now, I've already created a family for that purpose to save us some time. But remember the table and chairs example from an earlier video? You can have a parent family like the table that has other families nested in like the chairs. Well, in this case, we've got a parent family, the pool table, and we're going to have the accessories nested in as a subfamily. So we're going to go to Create here, click the Component button. It will tell us that we don't have any component families loaded and ask us if we would like to load one. Let's answer yes. And then in the dialog that appears in the exercise files folder, I have created a family called Cues and Balls. Select that, click Open. That loads that family in and places it on my cursor for placement. Now, notice it says click to place an instance on a face. So this is what we call a face-based family. And the easiest way to demonstrate this is to show you some examples. You could place it on any surface on this family, including even the curved surface here on the legs. Now, I don't think those make sense, but certainly the tabletop surface does. So I'm going to start highlighting that surface. It's pointing the wrong way, space bar to rotate it 90 degrees, and then I'll just click somewhere to place it. Click the Modify tool to finish, and I think that really is a nice final touch there. So at this point, our pool table is complete, and the final test is to load it into a project and make sure that everything works as expected. So I just happen to have our condominium building loaded here in the background. So what you can do is, using the buttons on the Family Editor panel here, you can either load it into the project and leave the family open, or you can load it into the project and close the family file. So we're done working on this family, so I'm going to load it into the project and close. It'll ask if I want to save it. I'll answer yes. That closes all of those windows and takes me to the one open window of our condominium building here. And I'm going to zoom in close on the right-hand side and place an instance of it here in this rec room. And then I'll click the Modify tool to cancel. So now if you come back and select it, you can see that both of your sizes loaded in, large and small, and you can try each one and settle on the one that you like. And then if you really want to see this pool table in action, then what I recommend that you do is come over here to the 3D dropdown, choose camera. I'm going to stand over here in the common room and drag a camera towards the pool table like so. That is going to look directly at the pool table. You can adjust this view if necessary. And then let's turn on shading so that we can see our green felt. And at this point, we can confirm that everything is behaving the way that we expected. And so I always recommend that the final step is to load it into a project to test it out. But that completes our pool table family. And now you should have a pretty good idea of what the overall process is of creating a fully parametric piece of family content.